so I don't forget to do that. All right, this week we are starting on our, I think we have like 3 weeks of sequence and series. This week we just talk generically about sequences. Next week we talk about arithmetic sequence and series, and then the next week we talk about geometric sequence and series, and then I think we end it with probability. So it's a fairly easy way to end the year, but you know, some of the problems this week are going to cause a little bit of heartache for some, no question about it. Okay, so sequence and series is what the concept is. The first thing we're talking about is a sequence. A sequence is just a list of numbers. You know, for example, if I had, you know, if I gave you something like, oops, better turn on my marker here. Something like 2, 4, 6, 8, ... This is called a sequence, and this is the first term. This is the second term, and usually we call this like this is ace of 1, this is ace of 2, and if I wanted to write an equation for this, an nth term we call it, this would be ace of n is equal to, what would that be, 2n. I think 2n would do it, because if you put 1 in here, you get 2. If you put 2 in here, you get 4. So this is called the nth term. This is an explicit formula. An explicit formula is really nice because if I asked you for the 100th term, all you do is you'd put 100 in here and you'd end up with the 100th term to be, so ace of 100 would equal 200. You wouldn't have to write them all out. So this is a basic sequence. A recursive formula always has 2 parts, okay? So I just talked about an explicit formula. A recursive formula is a little bit tougher. A recursive formula, it gives you the first term. So it'll say like ace of 1 is equal to, let's say, 10. And then they might say ace of n is equal to 2 times ace of n minus 1. Well, a recursive formula, this ace of n minus 1 really means the previous term. So it means the previous term. So my first term is 10. If I want to get to my second term, I take 2 times my previous term. Well, my previous term would be 10. 2 times 10 is 20. So that would be your second term. If I wanted to find the third term, I would do 2 times the previous term, which is 20 now. So that would give me 40. If I wanted the next term, I'd go 2 times 40, which is 80. So a recursive formula, you need to know the term directly before it to come up with the next term. So here they have a recursive formula. It says ace of n is equal to 2 times the previous term plus 1. Well, the first term is 4. So if the first term is 4, 2 times 4 is 8 plus 1 is 9. So that would give me my next term. And then 2 times 9 is 18 plus 1 is 19. That would be my next term. And that's how I keep getting the next terms. Now, the hard thing about this is that when you do a recursive formula and I say, what is the 100th term? You have to come up with every single term previous to it. You'd have to come up with the 4th term, the 5th term, the 6th term, the 7th term, the 8th term, all the way to 100. That's why we don't use recursive formulas that often, but they are not that, I mean, they're not that hard. It's just you have to realize that you have to use the previous term to get to the next term. That's what recursive means. Then we also talk about factorial notation. Factorial, like for example, if I said, what is 4 factorial? You would say, oh, that's 4 times 3 times 2 times 1, which is 12, 24, so that would equal 24. So 4 factorial is 24. Now, you're going to have to simplify some factorials down tonight, which I get into some really cool ones. Like, for example, if I asked you, what is 100 factorial over 99 factorial? Okay. Do you guys know what that answer would be? What would that answer be? What is 100 factorial over 99 factorial? What would my answer be? 100. That's exactly right, because 100 factorial would be 100 times 99 times 98 times 97 ... And then 99 factorial would be 99 times 98 times 97 ... So all of these would just cross off all the way down to 0, and you'd just be left with 100. What if I asked you for something crazy like this? N plus 1 factorial over n factorial. What would that equal? This takes a little bit of thought, but I mean, if you think about it, it's very similar to the last problem that we did. Uh-oh, no answers? 1? Nope, not 1. Question mark? Nope, not question mark either. Okay, so let's pretend n is 10. So let's put 10 in there. So this would be 10 factorial on the bottom. On top, it would be 11 factorial, wouldn't it? So if I work this out, I'd end up with 11, right? So if you think about it, n plus 1 factorial, n plus 1, this would be n, and then times, well, this would be times, and then we keep going down, and then this would be n times, dot, 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 dot. So all of this would cross off. I would just be left with n plus 1. That's it. That would be my answer. My answer would just be n plus 1. We don't know what that number is. I mean, we don't know what n is, so our answer would just be n plus 1. Does that make sense? I mean, because if you had n plus 1 factorial, that would mean my first term would be n plus 1 times my next term would be n, right? Because it just goes down by 1. Well, n plus 1, if I subtract 1, I just get n. And then I don't know what the next term is, but it's going to be the exact same thing on the bottom. So all I'm left with is that n plus 1 there. It's kind of cool. I love those problems. They make you think about what's happening. All right, so that's factorial. We also deal with summation notation. Summation notation is this little symbol right here. So if I had n equals 0 to, let's say, 5 of 2n, this means I want to find the sum of all these. So I'm going to plug 0 in here. So 2 times 0 is 0. So that would be my first term plus. Then I'm going to put 1 in here. 2 times 1 is 2. Then I'm going to put 2 in here. 2 times 2 is 4. Then I'm going to put 3 in here. That's 6. And I'm going to put 4 in there. That's 8. Then I'm going to put 5 in there, and that's 10. Then I stop because the bottom number tells me where to start. The bottom number tells me where to start. The top number tells me when to stop. So after I plug in 5 into my formula, I stop. But then I have to add all this up, and that is what the sum of that is. Now, if I had a problem like this, if I had the sum of n equals 3 to 4 of 2n, well, then you put 3 in here. 2 times 3 is 6, plus, and then I put 4 in there. 2 times 4 is 8. Then I stop. I would just add these two numbers together. Boom, done. So that is summation notation. And you should have seen, obviously you should have seen factorials and summation notations back in Algebra 2. Just a real quick refresher. And if you didn't understand that, make sure you watch the lesson tutorial this week. There's a lot of stuff in there, okay? And then this is just a definition of summation. You can have a finite series, which means it stops at some number. And if you have an infinite series, that means it goes on forever. You just keep adding numbers up together. All right, let's see what the practice has for us today. It says find the third term of the sequence a sub n is equal to 8n plus 9. Now, this is an explicit formula. Why do I know it's explicit? Because they don't tell me what the first term is. If they tell you so it doesn't give me the first term. That's one reason I know it's explicit. And it doesn't also have this in the problem. This is a big hint that it's a recursive formula, and it's a little bit harder. This is an explicit formula. I want to find the third term. I just plug 3 in for n. 8 times 3 is 24, plus 9 is 33. Done. That's it. If it's an explicit formula, super easy to find each term. All right, this one I'm going to let you guys do. Find the fourth term of the sequence. A sub n is equal to 1 over n plus 3. Okay, what should my answer be there? What is the fourth term there? D, 1 over 7 is correct. Because I want to find the fourth term, I just plug 4 in there. I end up with 1 over 7. Done. That's it. All right. Find the second term of this sequence. Second term. I'll let you guys figure that one out. You guys should be able to do that. What is the second term? Letter D again. I agree. Because we have -1 to the second over 2 to the sixth. Well, -1 to the second really is -1 times -1, which is 1. 2 to the sixth is 64. Letter D is correct. Yes. Now this is a recursive formula. Why do I know it's a recursive formula? It gives me the first term. It also has that a sub n minus 1 in there. All right. So it says find the third term of the recursive defined sequence. All right, I'm going to let you guys work a little bit, see if you get the correct answer. So the third term there is what? And remember, the recursive formula, you have to find the first term, you have to find the second term, and then you have to find the third term. And that's the one thing about recursive. You have to find each of the ones previous to it. Letter D again? No. Let's check it out. So I know the first term is 8. Now to find the next term, I do 8 minus 6, which is 2 times 6. So that's 12. So my next term is 12. So then to find the next term, I take 12 minus 6, which is 6, times 6, which is 36. So I'm going to say my third term is 36. Ah, that is letter D. Very good. Awesome. Okay, Wesley, did you get the same thing? Letter D? Okay. Find the fourth term of the recursively defined sequence. Oh boy, this one's going to be a little bit tougher. I don't even want to do this one. Yikes. Oh, the fourth term. Okay, I will turn off my mic and let you guys work on this one for a little bit because this one's a little bit tougher. No question about it. Letter D again? Oh boy. All right. So if I was going to do this problem, which I really don't want to do, first term is 5. Okay, get the first one. Second term shouldn't be too hard. Just put 5 in here. So 1 over 5 plus 5, which is 10. 1/10. Okay. So now I've got the second term. The third term, now I have to put 1/10 in here because you have to put the previous term in. Oh boy. All right, so that's going to be, is that 50 over 10? So that's 51 over 10. So that's 1 over 51 over 10 or 10 51st, I think. So I've got 2 terms, right? So now to get the third term, I have to go 1 over 5 plus 10 over 51. I'm hoping I got that one right. Boy, so I need 51 as my common denominator. All right, so 5 times 51. I really should have did it this way. That's 225. So 225 over 51. So that gives me 235. So 1 over 235 over 51, which if I flip it over, it's 51 over 235. Oh boy, I messed up something because that is not the right answer. Yikes. Shouldn't it be 255? Well, where did you get 255? 5 times, that's 5. Oh, 20, oh, 2. Yeah, I don't know how to add or multiply. Whoa, okay. So 255 plus 10 is 265. So if I flip it over, I end up with 51 over 265. Whew. Yeah, there you go. So letter D is correct. Yeah, when you multiply 51 times 5, you really should get 255. Okay. Yeah, and this is being recorded. Yikes. Don't like it when we're recording the wrong answers. Okay. So now, tonight, on the assessment, these are the toughest types of problems that I can give you. And you've got to, this is multiple choice here, but on the assessment tonight, it's not multiple choice. And it says find the nth term of the sequence. Well, what that means is it wants you to find an equation for this. Okay, so, and next week we're going to be dealing with arithmetic sequences, and the following week we're going to be talking about geometric sequences. But this week, they're just regular sequences that you have to just look at and see if you can come up with an nth term. So for example, this one here, it's always going up by 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So it's always going up by 4. So a sub n, I know is going to be something like 4 to the, let's say, if I wanted to say to the nth power. Okay? So if I put 1 in here, 4, so a sub 1 is equal to 4 to the first, which is 4. If I put 2 in there, a sub 2 is 4 to the second. Well, that is 16. If I put a sub 3 in here, that would be 4 to the third, which is 64. Well, that looks like it works. This looks like it works. Now, let's say I gave you a problem like this, okay? Because this is an easy one. I want to give you a hard one, or something that you might see this week. What if I gave you something like this? 1/2, 3/4, 5/8, and 7/16. And I said, write an nth term for that. Okay. Now, most students would not be able to do this. Okay. My suggestion is you don't look at the fractions. You look at the top and you look at the bottom. So the top, I have 1, 3, 5, 7. Oh, so it's always going up by 2. So how about 2n minus 1? Is that okay for that top function? Because if I put 1 in here, 2 times 1 is 2 minus 1, that gives me my first term. If I put 2 in here, 2 times 2 is 4 minus 1 is 3. And then I look at the bottom. 2, 4, 8, 16. It looks like it's being multiplied by 2, so it looks like 2 to the n. So this would be the nth term for this. I look at the top, and I come up with an equation for the top numbers, and then I look at the bottom. Sometimes it's not, you can't do that, but most of the times when it's a fraction, you can just do the tops and the bottoms. Okay, so that's probably one of the hardest problems on the assessment tonight is where you have to come up with your own nth term. That means you have to come up with a formula for it, right? Those are the toughest ones. Okay. It says find the indicated term of the sequence. A sub n is equal to -1 to the nth times 2n minus 3. It wants you to find a sub 14. So it really wants you to find the 14th term. So if I was going to do this problem, I've got -1 to the 14th times 2 times 14 minus 3. Now, -1 to the 14th, anything to a negative number to an even power is always positive. So it's going to be positive 1. 2 times 14 is 28. 28 minus 3 is 25. So really, I just have 1 times 25, which is just 25. Holy cow, when in doubt, choose D this week. Looks like all my answers are D. All right. Next problem. I'm going to let you guys work on this one. This is a summation problem. I've got n equals 0 to 4 of 3 minus 2n. Okay. Tell me what the sum of that sequence is going to be. Yikes, I'm sitting here talking and I didn't have my mic on. Love doing that. All right, so if I put 0 in here, I've got a 3 minus 2 times 0, which is just 0. So I've got 3 plus, I'm going to put 1 in here. 3 times 2 times, that's -2, so that's going to be 1. Plus, I'm going to put 2 in here. So that's 3 minus 4, which is -1. Then I'm going to put 3 in here, so that's going to be 3 minus 6, which is -3. Then I'm going to put 4 in here. That's 8, -8. So 3 minus -8, that's -5. And then I'm going to stop right there because I've started with 0. I kept going until I got to 4, and then I stopped. So this, and this all cross off because they're opposites. So -5. I'm going with the letter A. That should be the correct answer. So that is summation notation. Write an expression for the apparent nth term. Assume that n begins at 1. Okay, so we're going to write an equation for this. So we got 5, 8, 11, 14, 17. In this problem, it looks like it's always going up by 3, doesn't it? So I know if it's always going up by the same term, I know that this has to be part of my answer. And then 5 is my first term. So what if I put 2 in here? Does that work? So assume n begins with 1. So if I put 1 in here, 3 times 1 is 3 plus 2, that gives me my first term. If I put 2 in here, 3 times 2 is 6, plus 2 is 8. That seems to work. I've got 3n plus 2. Yay. All right. Write a formula for the general term of the nth term. A sub 1 is equal to 2. So the first term is 2, 6, 18, 54, 162. All right, let's see if you guys can figure this one out, see what you get there. Letter A. I'm going to disagree with that. And the reason, okay, here's the reason. Because they say a sub 1 is 2. So if I took A as my answer, that means if I put 1 in here, I should get 2, right? Well, 3 to the first power is 3. 2 times 3 is 6. That would be the first term. So if I was going to ask you to write the first couple terms here, well, the first term is 6. And if I put 2 in here, 3 squared is 9. That's going to give me 18. So it looks pretty close, except the first term is not right. Now, what if we put n minus 1 there? 2 times 3 to the n minus 1. So now if I put 1 in here, 1 minus 1 is 0, so that would give me 2 times 3 to the 0. 3 to the 0 is 1, so 2 times 1 is 2. Ah, that gives me my first term. And then if I put 2 in here, 2 minus 1 is 1, so 2 times 3 to the first, that's 6. That gives me my second term. So I'm going to go with letter B instead of letter A. And the reason is because the first term is not correct with letter A, but it is with letter B. Does that make sense? Now, if they said, if this, oh no, it's not recursive. This is definitely not recursive. The n minus 1 here is the exponent. This is, I mean, it's hard to read, but that's an exponent. It's not recursive. Okay. This is just a explicit formula. Now, if they would have said a sub 0 is equal to 2, then I would agree with letter A for the answer. Because if I put 0 in here, 2 times 3 to 0, 3 to 0 is 1, 2 times 1 is 2, that would give me my first term as 0. So it really makes a difference on what they start with, if they start with 0 as your first term or 1 as your first term. This one, letter A, would work if they would have said a sub 0 is equal to 2. However, they said a sub 1 was equal to 2, so that means I have to use B would be my correct equation instead. Okay. So that was kind of a tricky little question there, but B should be the correct answer. All right. Any questions on any of that? It looks like that is the last problem on the practice for this week. And if there's no questions, we'll see you guys back next week, same place, same time. And hopefully you guys get outside tomorrow because it's supposed to be almost 80 degrees tomorrow. Woo woo! Gotta love that. Bye.